in cryptography, computer security, and software development. He has led a world-class group of engineers, scientists, and business executives, growing a global network of financial institutions using blockchain-based solutions to remove friction from global payments. We are running a little early actually this time, but I thank everyone for keeping that time. Appreciate it, and really over to David if he's here.
Thank you, Vineet. I hope everyone can hear me. Let me share my screen so you can see the presentation.
We can, David. Please do. I'll wait
Excellent.
for your screen to come up, and once I see it, I shall.
You
Yes,
should be
we
able
can
to
see
see my first slide now. Excellent.
Yes, please. Thank you.
Thank you. Bye. As Vineet said, my name is David Schwartz. I'm the CTO at Ripple and the co-creator of the XRP ledger. And today I'm going to talk about the XRP ledger, what it does, what it is, how it does it, and why we find it so exciting. First, let me tell you a little bit about the company that I work for. The company is called Ripple. We've established a global team of nearly 500 employees with 9 offices around the world. Our global headquarters are in San Francisco, other offices in New York, Washington, DC, London, Reykjavik, Mumbai, Singapore, Dubai, and Sao Paulo. We built the team to include experts in technology, finance, blockchain, and governance to enable an internet of value. And I always feel like I have to explain what the internet of value is. I think many of you have made international payments, and you probably know that moving money today could not be more different from moving information. If you've ever sent an email, it's virtually painless. You ask somebody for your email address and their email address, and then you just send the email to that address. You don't need to worry about what email services they use, what protocols, networks. You don't have to think about any of that. It just works. International payments are the very, very opposite. You do have to work out all the details, find compatible networks, find paths manually. It's extremely tedious. The internet of value is about making payments more like email. And I just want to back up a little bit about why that's important. The internet was a revolution in the delivery of information. We're still seeing the consequences of that revolution, but it was not unprecedented. There was a previous revolution in the physical delivery of goods. Things like the shipping container and breakthroughs in logistics and the computerized movement of physical objects has made it possible for me to order something from a factory in India or China. I live in the United States, and I can receive it in a couple of days at a very low price. And millions, billions of packages, ship around the world every day. That was a key enabler of global commerce, as revolutionary as the internet. And then the internet was that revolution in information. But if I can't pay, it's great that I can see what's available at some factory across the world. And it's great that they can get the products to me, but if I can't pay for them, it's a huge problem. And it's especially a problem in the sort of electronic goods. Imagine if you run a company in Africa and you want to advertise on Google, getting the money to them is like the last piece of enabling global commerce. So we feel like that internet of value, that third revolution in the movement of money, is the missing piece. So back to the company that I work for, Ripple. You can think of Ripple as having 2 parts, RippleNet and RippleX. RippleNet is focused on proprietary products for institutional customers. Primarily, you're talking banks and non-bank financial institutions, payment companies. RippleX is focused on open source products and public protocols for crypto adoption. The way I think about it is anybody in the cryptocurrency space is like Twitter in the 90s. Now, of course, there was no Twitter in the 90s, right? And if you had the idea for Twitter in the 90s, the problem you would have is that there's no target market for your product. You have this great idea for a product. Maybe people wouldn't think it was great, but you have no target market. If you were Twitter's marketing manager and I said to you, hey, I have a great idea how to get more people to have smartphones and how to get more people to have home internet access, you would think I was crazy. You would say, that's not our problem. Our target market is people who already have smartphones, people who already have home internet access. If people don't have access to Twitter, they're not our target market. This is the problem that everybody in the cryptocurrency space has. Like our target market, which is like people who are savvy about cryptocurrency and have access to wallets and DeFi, this target market doesn't exist. So we have to build it. So XRP is the digital asset native to the XRP ledger, and Ripple leverages XRP and its products for its speed, low cost, and green attributes. And that's where I'll focus most of my presentation today, the XRP ledger, the public, open source, permissionless blockchain for XRP and for other assets. It was built for payments first. We thought payments was the biggest problem to solve. Developers choose to build on the XRP ledger for its performance, its low cost, reliability and security, accessibility, and inherently green attributes. And I think you're going to hear those themes again. And I think those are the really important ones when you're picking a blockchain to build on. So the XRP ledger is an open source decentralized blockchain technology. That's kind of the price of admission to sort of be a blockchain that people are interested in using. Open source is absolutely critical. People have to be able to understand the rules that the system follows. And I'll talk more about how that's fundamental to blockchain, that everybody can enforce the rules. And it provides significant benefits such as scalability, speed, and cost. It's also trustless in a very specific sense. People throw the word trustless around, and it's not very helpful to throw around the word decentralized or trustless without talking about what you mean. So I'm going to be very specific. It's trustless in the sense that if you want to participate in the XRP ledger ecosystem, you can independently enforce all system rules. So there are very specific rules that talk about, how do you get XRP? How do you lose XRP? What can you do with it? What are the transaction fee you have to pay? All of those rules are enforced by every participant in the ecosystem. And so you can have a very, very, very high level of assurance that those systems' fundamental rules will be followed. It's the complete opposite of a bank. You log into your bank and the bank says you have $50,000 or 2,300 rupees, and you trust it because it's your bank. And if the bank is giving you information that's wrong, you would then go and appeal to your bank and say, wait a minute, you said I had more money yesterday. You say I have less today. What's going on? And you could even sue them. These systems work the opposite way. These systems work by formal proofs. If you want to tell me that I have less money today than I had yesterday, you have to prove it, because it's literally the only way you can tell me I have less money today than yesterday is to show me proof that I spent that money. And this is the way that you protect against malicious actors. But you still have the double spend problem. The XRP ledger uses a PBFT-like consensus algorithm. I won't get into too much technical detail about how the algorithm works, but it's neither proof of work nor proof of stake. You also have a transaction spam problem. The ledger has no idea what's legitimate economic activity. So I could take 50,000 accounts and bounce XRP between them in a circle all day long. And the ledger, because it's decentralized, wouldn't know that that doesn't represent legitimate economic activity. So it uses XRP to reduce transaction spam. To send a transaction on the XRP ledger, you have to destroy a very, very, very small amount of XRP, like a microscopic amount, but at least it is something scarce. It's a multi-asset ledger. XRP is its core native asset, but it also supports what we call issued currencies, which kind of act like IOUs. Financial institutions using it today leverage the XRP ledger for its ability to fully settle transactions for tiny fractions of a penny, microscopic amounts of money, in about 5 seconds, which is faster than any other major blockchain. If you're interested in moving value, XRP is a much better choice than Bitcoin. On pretty much every metric, XRP wins. If what you care about is things like cost, scalability, speed, efficiency, reliability, predictability, XRP ledger wins at least over Bitcoin and probably ETH too, and most of the major blockchains on all of those parameters. I do want to talk one more second about predictability, which I think is important. XRP doesn't have Bitcoin's block time variability or Ethereum's fee variability, and that's because it doesn't use proof of work or proof of stake. It uses a sort of distributed agreement algorithm. Now, I know this is going to be controversial, but the fact is that proof of work provides mediocre decentralization and pretty good security at astronomical cost. And by cost, I mean both money and environmental impact. That proof of work provides everyone an equal opportunity is false. Many of us thought so in 2012 or so in the early days, but we know it's not true today. It grants money and control to whoever has the cheapest, often subsidized power, and the best ASICs or GPUs. And let's be clear, the money that miners pay to ASIC manufacturers, GPU manufacturers, and power companies is value that was generated by the cryptocurrency ecosystem. So Bitcoin has to generate millions of dollars a day of value just to hold the price of Bitcoin constant, because the newly minted Bitcoins are sold by miners. This is effectively a tax on cryptocurrency users. It's an inflationary tax. I know it's become popular lately to judge the utility of a cryptocurrency ecosystem by the amount of fees paid, but I think it's worth thinking about what fees actually represent. What they are a friction that's not removed. They're bad. If you think about eBay, eBay makes money because buyers and sellers find it easier to use eBay than to try to reach each other directly. eBay provides conduits for money to flow. It provides reputation management, listing, search. It provides all these features that provide a benefit to both buyers and sellers. And if buyers and sellers find it useful, they'll use eBay, and eBay will make a lot of money. And the more useful they find it, the more money eBay will make. But don't forget, every dollar that eBay makes is a dollar that a buyer spent that a seller didn't get. There's residual friction in the system. So while fees are to some extent good, eBay wouldn't be making a lot of money if it wasn't reducing a lot of friction and making a lot of payments and transactions better than they would be without eBay. They're also bad. The bigger the fees, the more friction eBay has still created. The more work there still is to do if you're a buyer or a seller. Obviously, if you're a stockholder of eBay, you're happy that eBay can keep a lot of friction in and still make money. But let's not forget that those fees represent friction that is still experienced by the buyers and sellers. All other things being equal, an eBay that made less money on the same transaction volume would be better for buyers and sellers. And if you're looking at a cryptocurrency system, you're the buyers and sellers, right? You're not eBay. The XRP ledger is different because its core consensus mechanism is different. In the early days, looking at Bitcoin, I thought, just like everybody else who was in the ecosystem at the time, that proof of work was the sort of unobtainium, the magic, the secret sauce, the thing that made Bitcoin different and better. And as I looked at it more closely, I came to realize, I think as most people know today, that the proof of work is not so much the magic part of Bitcoin. It's important, sure. It's a core part of Bitcoin, but it's not what gives it most of the properties that we care about the most. It turns out that what gives Bitcoin most of the properties that we care about the most is the fact that it has no administrative functions. It has public state and public rules and global enforcement. So by that, I mean, anybody who participates in the Bitcoin ecosystem can see the state of the Bitcoin blockchain at any time. They can understand who has how many Bitcoins, and they can look at transactions and determine if they're valid. They can execute those transactions themselves. Essentially what that means is, if I want to pay you 1 Bitcoin, I have to convince you that I got a Bitcoin and gave it to you in compliance with all of the system's rules. There's no administrator or central party that keeps central track of who has which Bitcoins. It's independent proof to each participant. That's the unobtainium. That's the secret sauce. That's the magic. Proof of work does 2 things in Bitcoin, and they're important. I'm not going to minimize that. They solve the double spend problem, and they solve the initial distribution problem. The double spend problem is the most interesting one. This is the problem that if Alice has a Bitcoin and Alice can send that Bitcoin to Bob, or Alice can send that Bitcoin to Charlie, there's nothing to stop Alice from attempting to send the same Bitcoin to both Bob and Charlie. And both of those transactions are valid by all system rules. There are multiple equally good ways a blockchain can make forward progress. And if we didn't have some way to agree on whether Alice sent the Bitcoin to Bob or Charlie, imagine if in Bob's world, Alice sent the Bitcoin to Bob and Bob sends it on to Dave. And in Charlie's world, Alice sent the Bitcoin to Charlie and Charlie sends it on to Eric. After a while, the Bitcoin ecosystem could become so messed up with so many multiple transactions for the same Bitcoins that there's no way that we could agree on who had a Bitcoin or who sent it to whom. And the system would just degenerate into a mess. And so you need some form of eventual agreement. It turns out that that problem is not as difficult to solve as I initially thought. And I'll talk about that a little bit more later. But I want to talk about 2 features in the XRP ledger that are innovations beyond its consensus mechanism. And that's views and invariant checking. Views are the way transactions execute inside the XRP ledger. They don't execute on the ledger directly because the ledger is cryptographically secure and it's computationally intensive to make processing against the ledger. So they operate on something called a view, which you can think of as sort of a cache. And that makes possible many things, but the biggest one is invariant checking. Now, many of you who have been in the cryptocurrency space for a while know about the DAO attack on Ether, which was an attack that stole a significant amount of money from a sort of decentralized autonomous entity called the DAO. And it was due to a bug, a reentrancy bug. And these are the kind of bugs that are very difficult to catch. And one of the things that I worry about is, what if there's a bug in the XRP ledger software, which, I can't guarantee you that there isn't. There probably are bugs. We're humans, we make imperfect software. So let's take a worst case imaginable bug. So in 2013, there was a bug in Bitcoin that allowed somebody to create an unlimited amount of Bitcoin, and it did some damage. We're fortunate the ecosystem was a bit smaller then, and so it didn't do as much damage as it could do today. So let's imagine hypothetically there's some bug in the XRP ledger software somewhere that allows you to create an unlimited amount of XRP. The problem with finding and fixing such a bug is there's hundreds of thousands of lines of code that handle all different transactions. It isn't going to be like, one piece of code that says create XRP and it's well commented and easy to understand. It's going to be some subtle bug deep in some complicated transactor, or worse, put in maliciously and carefully hidden. And the problem is the attack surface is large. There's an enormous amount of code you would have to go through to convince yourself that there wasn't a bug anywhere that allowed someone to create XRP. Well, that kind of sucks. What invariant checking does is when every transaction executes, before it modifies the ledger, it creates a view. And that view will say things like, take 20 XRP from Alice, give 5 XRP to Bob, and do all these other things. The invariant checker is a very small piece of code that looks at the view, and it says, does this view create XRP, or does this view break any of the rules of the system that no transactor should ever break? And if it does, let's say someone found a bug that allowed them to create XRP and their transactor created this view that made more XRP, the invariant checker would just throw the view away. It would say, this view is invalid. It would throw it away, and it would replace it with a new view that contains an error code that says this transaction broke a system rule. And if that ever actually happened, fortunately, it's never happened, but if that ever actually happened, we would know that there was a bug somewhere in the XRP ledger software that would have created XRP, but for the invariant checker. And that allows us to be protected against whole classes of serious errors. And that's a major innovation. But the XRP ledger isn't just XRP. It supports what we call issued assets. These are represented as a balance between two accounts. The core concept is a lot like traditional banking. If you have $1 in the banking system, what typically happens is a bank owes you $1, right? Your bank balance is an amount of money that the bank owes you. So to pay someone a rupee, you could make a bank owe them a rupee. You and I don't have to use or trust the same bank for the payments to work, right? What happens when you get paid by your employer is some bank owes your employer less money and some bank owes you more money. And they're two different banks. You don't have to trust the same bank your employer uses. Your employer doesn't have to know or think about what bank you use. Except the XRP ledger permits anyone to issue assets, but it has an interesting constraint. And that is that you can only owe an asset to someone who has agreed to accept it. If many of you have used Ethereum, you know that you can wind up with huge piles of worthless assets. And it can get worse. In payment flows, you can sort of wind up with something called a worthless intermediary asset. So say you want to pay somebody dollars and you have rupees. Someone could tell you that there's some intermediary asset that you could buy with your rupees that would allow you to get the dollars you need to make the payment. And then it turns out they sort of withdraw that offer. It's like they sort of fake you into buying an intermediary asset that you think can complete your payment. But that can't happen here because nobody can have an asset they didn't agree to hold, and payments are atomic. The XRP ledger has a decentralized exchange, or DEX, to provide liquidity between different issued assets and between issued assets in XRP. It was the world's first DEX. Sophisticated payment and trading features make this multi-asset system work smoothly. You can pay someone in dollars, even if you don't have any dollars, just by specifying that that's what you want to do. And the pathfinding system will tell you how many rupees or how many XRP or how many of whatever assets you have it will cost. And if you have more than one asset, it will give you payment options. I truly believe the XRP ledger is the best decentralized blockchain for payments. And in the early days in development, I kind of thought payments were enough. I mean, it's a massive problem. There are huge problems with the way international payments work. And I thought solving the payment problem, would be enough. The whole build a better mousetrap and the world will beat a path to your door. Well, we built that better mousetrap. And I guess payments just aren't exciting enough. So let's talk about what else you can use the XRP ledger for. If you don't think payments are exciting enough, let's talk about what else you can do. So in June, I published a vision to bring federated sidechains to the XRP ledger to enable developers to implement new features while also allowing the XRP ledger to maintain its existing sort of lean and efficient feature set. So what is a sidechain? A sidechain is a secondary blockchain connected to the main blockchain that can have its own assets, its own logic, its own consensus protocol, its sort of own rules. What makes a sidechain federated is a federator. I'm sure many of you have seen Star Trek. You know that the Federation is sort of a loose alliance. It's sort of a group of entities that don't fully trust each other, but that cooperate through a set of very precise rules to achieve things that they couldn't achieve as efficiently or at all on their own. The federator in the federated sidechain world is a piece of software that connects multiple instances of the XRP ledger software. Federator might be connected to the XRP ledger mainnet on one side, and it could be connected to a private or public sidechain on the other side. So what does this do? Well, first of all, it sort of solves a painful trade-off problem that you have. Like Bitcoin and ETH have this painful trade-off problem that ETH has very few features, but it's very predictable. ETH has a lot of features, but fees can be unpredictable, loads can be unpredictable. It's very difficult to build one blockchain that can handle all use cases. Payments don't really want to live on the same blockchain as DeFi. NFTs don't really want to live on the same blockchain as payments. CBDCs don't want to live on the same blockchain as like native digital assets like XRP and Bitcoin. And so having multiple chains allows you to solve that. It also allows people to innovate at the very lowest layers. And this is exciting in the blockchain itself. You don't have to live with the existing trade-offs that don't match your use case. So for example, if you build a DeFi product on top of Ethereum, you get Ethereum's fees. If you don't like Ethereum's fee structure, tough, don't build on Ethereum. But if you want access to Ethereum's ERC20 assets, like you have to build on Ethereum. But now you get Ethereum's fee structure. Or say you need large amounts of storage or you need GPU computation. Well, Ethereum doesn't provide that. So, you have this trade-off that you have to sort of match, you have to match your use case to what the blockchain provides. But if you can innovate right at the blockchain layer, then you don't have that limitation. Sidechains also offer horizontal scalability, which I think is big. You want to execute more transactions, you can just add more sidechains. Each sidechain has its own capacity and capabilities. And what's also interesting is if you need to execute transactions across sidechains, let's say you have, too many senders and many receivers. And if you have to put everybody on the same blockchain, well, then you lose most of these benefits. Some of those senders might like DeFi and some of the receivers might just want to receive payments. Well, if you have 100 blockchains, you have 100, times 50 times 99, you have 9,900 possible paths that a 2 blockchain payment can make. And so what you've done is by just doubling the cost of a payment, essentially you make a transaction on 2 blockchains, you've increased by many, many hundred the number of possible sources or destinations that you can reach. And if the cost of a transaction is so small that it's almost negligible, doubling it is also negligible. And if the transaction time is 4 or 5 seconds, well, an 8 to 10 second payment, 16-second payment is still pretty darn good. It's still competitive with most major blockchains. So you can have these cross sidechain payments or cross sidechain transactions that give you monster scalability. Federated sidechains allow developers to implement new features such as CBDCs specific to their own needs alongside the XRPL mainnet. And I want to talk a little bit about CBDCs because I'm very, very excited about them. And I'll talk about some of the naysayers. So our CBDC private ledger enables central banks to create a private parallel network for permission blockchain to issue the CBDC on. So for those who may not know, a central bank digital currency. We're talking about central banks issuing, the country's primary fiat asset on a private blockchain. So they can issue the CBDC and they can connect that to the main public XRP ledger or other CBDC chains. And the vision is to solve for interoperability between CBDCs while creating a sort of virtual lab for central banks to experiment with new XRP ledger features. So one thing that I commonly hear is that why would you use a blockchain for that? Why wouldn't you just use a regular database? Like if it's centralized and it's permissioned, what's the advantage of a blockchain? Well, transactions on the CBDC private ledger are verified by the same consensus protocol used by the XRP ledger. Not quite exactly the same, but very, very close, almost identical. It's far less energy intensive, less expensive, and 120,000 times more efficient than using things like proof of work. But it provides comparable security to public blockchains. And this is extremely important. If you look at enterprise payment systems, SWIFT, for example, you'll see stories all the time about sort of compromises of the SWIFT system where somebody sort of gets through SWIFT's outer layer of defenses and then they can compromise the system from the inside. Blockchains don't have that problem. If you think about the Bitcoin blockchain, Ethereum, the XRP ledger, all of these blockchains have billions of dollars moving around them, and they simply don't have those types of security problems because they don't have a central database you have to defend. They don't have a central party. They don't have the security vulnerabilities. So this is big, and building using blockchain technology can make these systems more open without sort of having that security problem. And the next question I hear is, well, so what? We already have digital money. So if we build these CBDC systems, why don't we just have the same, most people who have money don't have physical bills or coins in their pocket. But this is a major first step in providing central banks with a secure, controlled, and flexible solution for the issuance of digital currencies to enable global interoperability. So what does that mean? Imagine every major institution in the world, and I mean every major institution in the world, able to settle every major asset. That's dollars, that's rupees, that's euros, that's Japanese yen, you name it, with every other institution in a compatible jurisdiction. You're not going to see, US banks settling with North Korean banks, obviously. So again, every major institution in the world settling every major fiat asset with every major institution in a compatible jurisdiction in seconds for pennies or fractions of a penny. I mean, how is that not mind-blowing? Every institution in the world can move every fiat asset to every other institution in the world in seconds for a penny, as long as the jurisdictions are legally compatible. How is that not an incredible big deal? That can happen when the systems are independently secure and interoperable. That is a very big deal. Let's talk a little bit about DeFi and smart contracts. DeFi is a key focus for Ripple, specifically the Ripple X team, that sort of open source side, working on sort of grassroots crypto adoption and tools and services, protocols, programs for developers to make it easier to build new use cases on the XRP ledger. DeFi, if you look at what's going on in the DeFi space, at the core is payments, exchanges, and tokens. DeFi, if you imagine a DeFi application like loans, well, when I borrow the money, someone has to pay it to me. And when I pay the loan back, you know, I have to be able to make payments back. If I'm going to get a yield, I have to pay into the system that's going to give me a yield. It has to make yield payments out to me. Many DeFi applications need payments and exchanges and tokens. You know, you need some tokenized form of value. These are all things that the XRP ledger has proven success in. The XRP ledger and its built-in DEX, which was the very first decentralized exchange, has been operating for 10 years without incident. As DeFi continues to grow, innovations to the XRP ledger, such as federated sidechains, can allow for more developer experimentation. Developers in the XRP community are already hard at work proposing features that would bring smart contract capabilities to the XRP ledger. And I want to call out one thing called the Hooks Amendment. This came from XRPL Labs, Wee Tzu Wind, and Richard Holland. It's pretty brilliant. It could integrate with an XRPL federated sidechain or be implemented on the XRP ledger mainnet. And what I like about Hooks is it gives you a very significant fraction of the feature set that you get from essentially like a Turing complete full implementation of DeFi or smart contracts. You get a very valuable and significant fraction of that without some of the downsides, without some of the costs and fee unpredictability. So it's a sort of leaner, meaner version. And while you can't do literally everything that you could do in a generalized DeFi implementation, you get a very, very valuable fraction of them at a much, much lower cost. Super exciting. So we understand you have a choice of blockchains. That's from some old commercial, probably none of you have ever heard of. Why would you want to build on top of the XRP ledger? Why is that the blockchain that you might want to build on? Well, one thing that I think is worth calling out for developers is that the integration complexity of the XRP ledger is low. You don't have to stitch together multiple pieces, and there's a single API that the XRP ledger's node software provides. Running your own node is easier than almost any other blockchain. You can download the software and have a node ready to process live transactions in less than an hour, just from nothing to completely ready to go in an hour. And this is something important. The number of blockchain experts in the world is not enormous. There are not, hundreds of thousands of blockchain experts. There aren't a lot of people with 10 years of experience in blockchain. There were zero not long ago. And the problem with a lot of other blockchain systems is you want to do something simple like create a wallet or receive a payment or make a payment, and you have to make 10 or 20, or well, 20 is probably not realistic, but 10, 13 API calls is realistic. And each of them might have, 5, 8 ways it can fail. And you have to properly handle every failure case. If you have 10 API calls, each of which has 5 ways it can fail, that's like 50 error handlers that you have to write just to do something simple like make a payment. And if you mishandle one of those error cases and someone finds out about it, there are ways that malicious participants can induce errors in your code. And if you don't handle them correctly, you can lose money. And so if everybody who wants to build, one of the problems, if you look at companies like Amazon, Airbnb, Uber, they have hundreds of payment engineers that make their payment systems work. If you want to build on a blockchain, you need hundreds of blockchain engineers. That's a complete non-starter. And so bringing the complexity level down through a simple API and good middleware is a primary focus of RippleX and the XRP ledger ecosystem. So you can hold, transfer, receive, and trade a number of assets with transactions that cost much less than a penny and fully confirm in less than 10 seconds. XRP Ledger's hyper-efficiency and liquidity enables developers globally to support numerous use cases from DeFi, payments, consumer applications. And you don't need anybody's permission to interact with the XRP Ledger, right? It's a public good. It's an open source, decentralized, there aren't administrators. You just submit transactions and everybody who participates executes them. It's so fast and so simple. I'm not making this up. I've had developers contact me with concerns when everything was fine because their payments were so fast, so cheap and easy. They were concerned that they couldn't possibly be doing it right. They're like, wait, no, it says it's confirmed. I must not have checked right because it's only been a couple of seconds. No, it's that fast. It's that cheap. It's that easy. I barely scratched the surface. I wish I had time to talk in detail about features like escrow, pathfinding, incremental payment execution, negative UNL, managed multi-signature, social money and credit, and many other features. You can find more at xrpl.org. Please, take a look and see what's available and how easy and how powerful it really is. Thank you. Are there any questions?
Thank you, David. I will quickly look at our chat to see if there are any questions. And thank you very much for that presentation. I'm sure a lot of people benefited from it. But still
My
looking.
pleasure.
Nope, I think no questions in yet, but it doesn't hurt us to wait for another few seconds. They always arrive just after the presentation is over and people kind of think about what they want to ask. And every time I let a presenter go, I suddenly see a couple of questions and I feel really guilty of not being able to ask them. So do give me a few seconds, please.
Sure.
And people who are watching this session, this is a good time to send in the questions whilst we keep David on the hook. Nope, and that is how much time I usually give, David. Thank you very much for joining us today and for your time. We really appreciate you making time for NASSCOM and NATC.
Thank you, Vineet. It was my pleasure.
Thank you very much. That, ladies and gentlemen, was David Schwartz, CTO at Ripple, and he was talking about under the hood, understanding the XRP ledger. Really brings us to the end of day 3. This was the concluding day, and as we come close to the the 8th edition of the NATC, this is the close. We would like to thank our core committee who helped put the conference together. Do join your hands for Shalini Mishra, Head Digital Transformation, Sopra Steria, Amit Gupta, Director Technology, Hughes System, Ashwini Nandini, Senior Vice President, Global Logic, Saurabh Jain, Founder, Fun To Do Labs, and Chetan Kalanki, Head Cloud Engineering, Impetus Technologies. We hope you had a good time attending the conference as much as we did organizing it and learning from the workshops and hearing
Okay, great. Are my slides up and everyone hear me okay?
Yes, indeed.
Okay, brilliant. Thank you very much. Great, it's fantastic to be here, if unfortunately only virtually. I've got a very strong fondness for Singapore. I was actually born in Singapore and went to UWC. So I remember crossing over the Ayaraja Expressway to go to NUS to go running on their running track. So, and hopefully soon we'll be back in Singapore at some point. But right at this exact moment, I'm the exact opposite side of the globe. I mean, I meant that figuratively, but I actually mean quite literally at the moment. I'm currently located in Barbados, and I think I work. I've got a very strong fondness for Singapore. I was actually born in Singapore and went to UWC. So I remember crossing over the Ayaraja Expressway to go to NUS to go running on their running track. So, and hopefully soon we'll be back in Singapore at some point. But right at this exact moment, I'm the exact opposite side of the globe. I mean, I meant that figuratively, but I actually mean quite literally at the moment. I'm currently located in Barbados, and I think I worked out if I actually start traveling through the center of the planet, I will actually come out pretty much in Singapore. So that being said, so we're here for a masterclass in payments and blockchain. And as I said, my name's Matt Hamilton. I'm the principal developer advocate at Ripple. I'm going to talk a little bit about Ripple and about the XRP ledger as we go along here. And then we're going to have a bit of an interactive session as part of this. So for anybody who wants to follow along, as part of the workshop here, we're actually going to install and make some payments on the XRP ledger. And to do that, we're going to use a wallet app called Sum. And I've got on the screen here 2 QR codes, one for iOS and one for Android. So if you want to follow along, feel free to scan those QR codes now and start downloading. It'll only take a minute, but you might as well do that now. If you want, I'll bring this slide back up later on when we get into the interactive session for people to scan it then and continue on. Okay, so let's start here. So a little bit about Ripple. So Ripple is a company of about 500 employees, 9 offices, including one in Singapore. And our goal is to enable the ability to move value as easily as you can move information today. So I can live stream video from the International Space Station to my desk. Yet if I try to make a payment from Singapore to Barbados, it'll probably take about 5 days. It'll literally be quicker for me to get on a plane with a suitcase full of cash. And in some cases, it may even be cheaper to make that payment that way as well. So the goal that Ripple are working on is to make payments accessible to everyone, accessible everywhere. Now, currently, the average global remittance fee is somewhere around about 6 or 7%. So if you're trying to send money overseas, then you're going to be paying about 6 or 7% in fees. And that disproportionately affects those that most need to be able to do that. And as you're probably aware, especially in Southeast Asia, you have a lot of people moving around, a lot of people working in different countries, sending money home. And this is something that can very much directly affect them. So this is the thing that Ripple are specifically working on. Great. Oh, and thanks, Marcus, for putting the links in the chat there. So if anybody has any questions, then put them in the chat, and I'll try and kind of get to them as we go along, or at the end. But feel free to put them in as we go along. So, understanding Ripple. So, Ripple is a company, and within Ripple there are 2 divisions: RippleNet and RippleX. RippleNet is the payments network that is used typically between banks and is very similar to, you might have heard of SWIFT, which is the international bank network. And RippleNet is kind of a similar concept to SWIFT, but a bit more advanced. The XRP ledger is a blockchain that is used sometimes in part by RippleNet. It's an open source, public, permissionless, decentralized blockchain that allows anybody to move value worldwide. So the relationship is the XRP ledger is, public, anybody can use it. RippleNet is a private network specifically for banks that in part uses the XRP ledger to source liquidity using XRP, which is the digital asset that is used on the XRP ledger. But anybody can build anything on the XRP ledger. It's completely open. And in fact, the Sum app that I showed you on the slide earlier is from a third party in the Netherlands called XRPL Labs that are doing a lot of building on the XRP ledger. So a little bit about blockchains. I'm aware that people coming to this talk probably have different levels of understanding about blockchains and about finance. So blockchains can obviously be used to solve a whole variety of issues, and different people, different companies, different projects are looking at solving different aspects, whether it be storing medical data and making that more easily accessible, dealing with things like royalties, personal identity, supply chain tracking, gaming. The area that we're going to be looking at specifically, or the area that Ripple look at specifically, is cross-border payments, as I mentioned. And the XRP ledger is really suited for doing payments. We're going to look at 4 trends here just to kind of set the scene. So the first is the tokenization of everything. According to the, I believe this is a figure from the World Economic Forum, 10% of global GDP is projected to be tokenized by 2027. And there's new forms of value to be tokenized beyond fiat, things like gold, stocks. You've probably heard a lot about NFTs, non-fungible tokens, which are very much in the news a lot at the moment. NFTs are tokens that represent things like artwork, property titles, items that can't simply just be replaced like for like with one another, but you can tokenize kind of one-off items and trade them and sell them. There's an explosion in use cases to come. So, like I said, you've heard a lot about things like NFTs and artwork. That is one use case. We're very much early in the market, and as with early technologies, it's a case of kind of coming up with a whole suite of applications and really seeing what fits and what works. So there's an opportunity for a very efficient token, and that's what XRP is and the XRP ledger, and I'll talk a little bit about its specifics as we go on. Trend 2 is the fragmentation of networks. So there's many specialized networks. There's not going to be one winner takes all. You've no doubt heard of Bitcoin, Ethereum, XRP. There's a lot of other blockchains as well and cryptocurrencies out there. And one of the big things is interoperability between them. And Ripple actually started a project called Interledger many years ago. It's now a draft W3C standard that is used to interact between different blockchains, right? And allow you to send value from one to another. In an ideal world, I should be able to send you some value regardless of what blockchain you're on, regardless of what form you want to receive that in. So in the same way that I can send you an email and I don't have to care whether you are on Gmail, whether you're on Microsoft, whether you're on an NUS hosted email service, whether it's something you've set up yourself, all I need is your email address. And hopefully we can reach that same kind of ubiquity and interoperability with blockchains and cryptocurrencies. The third trend, talking about DeFi. So DeFi is decentralized finance, and it's coming back. It's coming around due to a number of factors. So one is the erosion of institutional trust since the 2008 financial crisis. A lot of people are wanting to kind of do it themselves, right? They want to provide financial services or use financial services without needing to necessarily hand over control to some financial institution or centralized entity, or they want to be able to pick and choose different services much easier. So they want to get a loan from one area, they want to save with another area, and they want to be a lot more kind of piecemeal and be able to pick the best service that fits them, be that in terms of features, be that in terms of user interface and experience, for example. And a lot of this is around things like fees with regards to this. Now, you may have heard a lot about high fees on blockchains like Ethereum. The moment if you go to make a transaction on there, you're probably going to be paying about $50 US upwards per transaction, which doesn't really kind of fit into this whole idea of cryptocurrencies and blockchains necessarily making things cheaper. But there's a lot of other blockchains out there, including things like the XRP ledger, that are much cheaper and much more efficient. And the fourth trend I'm going to talk about is the rise of decentralized exchanges. So at the moment, if you want to trade something, you have to go to a centralized exchange. Now, be that stocks, and you have to buy and sell via a licensed stock exchange, or whether that's cryptocurrencies and you're going to the likes of Coinbase or Kraken or Bitstamp or whatever it is. Decentralized exchanges allow you to trade directly on the ledger. And that has the advantage that there is nobody that is controlling your funds. You are in control of your funds yourself. There's no one that can forbid you access to that. Now, the XRP ledger was the first blockchain to have a decentralized exchange way back in 2011, 2012, and allows the tokenization of any asset. So on the XRP ledger, we've not only got the native asset XRP, but also things like US dollars and euros. And I'm going to show you in a bit, how you can actually go ahead and tokenize your own assets on there as well. So I mentioned XRP. XRP is kind of a universal token of value, a universal vehicle of value. You can use it to transfer, move value around. So the way in which Ripple are using XRP is as a medium to move that value. So the way Ripple have a product called ODL, and what ODL does is use a local fiat currency in one country, buys XRP with it, sends XRP across to the other side of the world, and then XRP is then sold for local fiat at the other end, right? And that's one of the use cases of XRP. So the XRP ledger specifically is very cheap, it's very fast. So a transaction takes, a thousandth of a cent. Transactions are confirmed within 3 seconds. So compare that to the likes of Bitcoin, in which it might be 10 minutes to an hour for a transaction, sometimes longer. And Ethereum, again, you're talking several minutes for a transaction. The XRP ledger transactions are settled in 3 seconds. The costs significantly lower than most other blockchains. And one of the key things is it's very liquid. It's available on over 100 exchanges and many, many different pairings as well. So if you want to go between different currencies, the chances are you can go from that currency to XRP and or back again. So just to recap on a couple of its pieces, the XRP ledger, it's the OG DEX, it's the original decentralized exchange back in 2012. Like I said, it's very, very liquid. There's a lot of XRP trading about very easily compared to a lot of other sort of newer cryptocurrencies. And so companies like Ripple use it to supply liquidity to remittance companies, for example, Tranglo, Nuam, Coins, PH in the Philippines, do cross-border payments using XRP. It's very fast and it's very interoperable. So a couple of the built-in features of the XRP ledger, kind of getting into a slightly more technical bit here before we get on to kind of the workshop. The XRP ledger has the ability to issue assets, what are sometimes called IOUs on the XRP ledger, or tokens. So the XRP ledger, like I said, was the first blockchain that allowed the tokenization of assets. And so you can represent anything you want on the XRP ledger. So be that fungible currencies like, dollars, euros, yen, whatever it might be, assets such as, or commodities such as gold, for example, oil, you could all be represented in a tokenized form on the XRP ledger. And the XRP ledger allows kind of credit and balance limits to be set as well. So you can say, okay, I will hold these IOUs for whatever it might be, gold, but I will only allow up to a certain credit limit on there. And there's some very advanced features as well. There's a feature called rippling, which is where the company Ripple gets its name from, and the original network was called Ripple to start with, where it gets its name from as well. And that allows you to effectively make payments via a common creditor, right? So if I owe Keith $100 and Don owes Keith $100, and I can pay Don by just adjusting how much I owe Keith and Don owes Keith, right? So I can say, okay, I now owe Keith an extra $20 and Don owes Keith, $20 less, and I've effectively paid Don by paying off part of his debt there. So the XRP ledger is the first blockchain to actually kind of acknowledge these debt relationships and actually allow you to model them. So you can actually create some quite interesting financial applications based upon that. And as I mentioned, it's got a decentralized exchange. Unlike some decentralized exchanges on some blockchains that use what's called an automatic market maker, this is actually an order book exchange. So you actually place orders and say, okay, I want to sell 100 XRP for $80 or whatever it might be, or I want to buy 1 Bitcoin for however many Singapore dollars. So you can place and cancel orders on the order books, much like you would do, a centralized exchange like, Coinbase or whatever. And the decentralized exchange is actually used internally within the XRP ledger for cross-asset payments. So one of the great things being is I can say, okay, I want to pay Marcus he wants to receive 100 Singapore dollars. I've got euros. I can make the payment and say, hey, pay Marcus 100 Singapore dollars using the euros in my account. And it will actually use the decentralized exchange in the order books to convert those euros to Singapore dollars as part of that single transaction within 3 seconds, right? It's a single atomic operation. But what's great is that it will actually find the best route. So the best route might not be to go directly from euros to Singapore dollars, but it might be to go from euros to XRP to Singapore dollars, or euros to XRP to US dollars to Bitcoin to Singapore dollars, or whatever it might be. The XRP ledger will look across the order books and find the best possible path that will give you the cheapest operation to get the most you know, end currency from what you're paying with. So that's really pretty cool for, like I said, cross-border payments. That's one of the key use cases that people use the XRP ledger for. But again, this could be extended. I talked about NFTs. If you were issuing an NFT on the XRP ledger, this then means that you could accept payment in any currency. So you don't have to say, okay, you know, I'm selling this NFT for whatever, 1/10 of an ether. You can set the price and somebody could pay in whatever currency is available on the XRP ledger. So that's kind of a quick overview, a little bit of the XRP ledger and some of the functionalities. Now, we're going to get onto the interactive bit here and a bit of a workshop here. So I mentioned at the start about this wallet app called Sum. I've put the QR codes back up here and the links are in the chat as well if you want to click on the links to install Sum on your phone. Once you install it, it will come up with a welcome screen. Now, what I'm actually going to do is I've got my phone here and I am going to share my screen, my phone screen here. So 1 second here. And if I bring that over, I should be able to do this. And it says, and that's not letting me bring that into this screen. 1 second here. There we go. Right. So I've actually got my phone here on the right. So if we kind of go through this, so the first thing it'll do is it will ask you to set up a passcode on here. I've put in a default passcode. It's actually told me that's not very strong, so I put in something better. So I'm going to do that. I will, yes, I'll go for Face ID on here. There we go. Push notifications. So I'm just going to go through here. So the first thing it'll do is it will walk you through just reviewing a few texts to basically say that you understand that this is a what's called a non-custodial wallet. So what that means is that this wallet is storing your cryptographic keys to access your funds on the XRP ledger. Now, what we're going to do in this demo is we're going to be using what's called the test net. So this is a test network that runs in parallel to the main network. So don't worry, we're not going to be using real funds here, and you don't have to worry too much at this stage about necessarily you know, what you're putting in here, because these are all going to be test funds. Obviously, if you use this for real, then you're going to have to be a little more careful with things. But what we're going to do is we're going to walk through the process of connecting up a test account to this wallet. So like I said, feel free to follow along with me, because what we're going to do is we're going to actually live send payments. So what I will do is I will bring up the chat and we'll be able to send payments back and forth. So see here, get to the end here. And right, okay, so we've got to the bit here that just kind of says what's new in the latest release. So I'm going to close that. Now, the first thing I'm going to do is add an account. So I'm going to tap add account, and I'm going to import an existing account. So right here, I'm going to choose full access, and I'm going to choose here family seed, the middle option here, and click next. And it's going to come up and say enter in the family seed. So what we're going to do is we're going to import in a test account, and there's a service called a testnet faucet. Now, testnet faucet is a service that will create an account for you. So what I'm going to do is I'm going to bring up my camera here and just scan that QR code and open it. And this will take me to this testnet faucet. And if you scroll down, you'll see two buttons here, and you want generate testnet credentials. So if I tap on that, it's going to generate some keys for me. Now, you have two parts of keys here. You've got the public part, the address, which is the one that starts with R, and the secret, which starts with S. Now, the secret key is the bit that you want to keep private. You want nobody else to see. And you definitely don't want to be broadcasting it on a live show to everybody. However, this is the testnet, so this is not real funds. So it's okay for me to kind of be doing that. Now, oh, I've just noticed a mistake here. I've highlighted the address here. That's not the bit you need to copy. It's actually the secret. It's the lower down one. So sorry, I've just realized I got that wrong there. But that's the bit that you want. You want to copy the secret. So if you copy that and then go back to some app, then you can paste that into there, right? Now, hopefully if people are following along here, I'll just give you a second here. Hopefully people are following along. So if I do that, say next, it'll say, please confirm the public address. And that's the public address that was shown earlier, because there's a mathematical relationship between the secret address and the public address there. So it's able to derive that. So I'll just leave this testnet faucet QR code up a second here. People. Right, so activation. So every account on the XRP ledger needs a certain balance to activate it, right? At the moment, that is 10 XRP. Used to be 20 XRP, it's now 10 XRP, but this is kind of a deposit that is kept in the account. Now you can see this faucet here has generated 1,000 XRP. And like I said, this is not real XRP, this is just test XRP on the test network here. But the deposit, it tells you here that you need a deposit of at least 10 XRP. And so because the account has been pre-funded, because it's a test account, you will have that in there. So I'm just going to go for standard security. Next, you can give it a label, whatever you want to call it. I'm just going to call it test. Next, and it is complete, right? And it tells us our account is not activated for the moment, and we will fix that in a second. So hopefully people are following along here. If anybody has any issues here, then put it in the chat, but hopefully people are able to kind of come along here. So the next step, it says our account's not activated. Now it is activated, but some by default is looking at the main network. We need to switch it so it's looking at the test network, which is where our account is. So if you tap on the bottom right on the settings, little settings gear down at the bottom, and then advanced, and when that comes up, you want to tap on node at the top there. And you want to change that to the testnet. So you can just pick that first one, testnet.xrplabs.com. Are you sure you want to switch? Yes. So do that. And if I go back and go to tap on home, you will see hopefully now that you have a balance here. So it's 990 XRP. So remember, it funded it with 1,000. There's 10 required for a deposit. So it's showing you what's available here, which is 990 XRP. So hopefully people have got to this stage here. Now, if you've got to this stage successfully, then feel free to copy the code, the address. Now, just realize that if you're going to try and copy that address, you might not be able to paste it into the chat here, because the chances are you are operating on a phone and the app on the phone, and you're watching this stream on your laptop. If you do have a shared clipboard, you can copy that. I know that people might not necessarily have that set up there, but if you go tap on the address at the top, tap copy, you can copy that and paste it into the chat, and I will be able to send a payment to you. Ah, great. So we've got one person in here that's done that. So I can now copy that. If I copy that from the chat, I can then go into my app and I can send, say 10 XRP. I say next, and I put in the address. Now this is the address that I have just seen from the chat here. Turn next and slide to send it, and it will ask for your PIN, thumbprint, Face ID, and that has been sent. So hopefully, is that Reshma?
Yes, Matt, I received it.
Will have received. Fantastic, great.
Thank you.
Yeah, no problem. So, and I'll do one more, Alvina. So let's see here. If I go here and send, and say send, and I'm going to send as well 10 XRP. Paste in there. So it's Alvina's address. Next, send that. And so hopefully Alvina will receive that in a few seconds. And similarly, if I want somebody to send to me, if I hit request here, it'll bring up a QR code. So again, if anybody's watching, then feel free to scan that QR code. So what you do in Sum is, if you on the home screen down in the bottom, there's the middle icon that says Sum down here, this X and a tick in the center. If you tap on that, you can select QR code, and you can bring up, and you'll be able to bring up the camera and scan this QR code, and you'll be able to then send a payment to myself, right? And if anybody happens to do that, then it will show up on my phone as well. I think I've actually got do not disturb.
I've sent you 10.
You've sent me 10? Okay.
Yeah.
Oh, thank you. So if I click, there we go. So you can see it here, and I can actually see the, if I tap on events here, I can see the transactions. So there we go. So I've had 3 payments come in, 123 XRP, 10 XRP, 10 XRP. So there we go. So this is Sum, this is the XRP ledger. You can see just how quick it is to make these payments. And each one of these transactions is, you know, it's about 1/1000 of a cent. It's 10, the default fee is 10 drops. So within XRP, so you have within each 1 XRP, you've got a million drops. That's the kind of the smaller subdivision currency drops, and it's 10 drops to send a payment. So it really is a very small amount there. And as you can see, you know, it's very fast. I wouldn't be able to live demo this on something like Ethereum or Bitcoin, because we'd still be waiting for the transactions to come through. So there we go. You can see the transactions actually going through real time, which is great. So the next thing I'm going to show, and feel free to, you know, play around with this yourself. Like I said, this is test XRP. You can send stuff backwards and forwards to each other. You can send the link or addresses backwards and forwards. There's other things you can do on here as well. There's things like address books in here as well. So you can actually go in here, you can return a payment, and you can put in memos in here, for example. There's even like an address book as well. You can put people in like an address book as well there. So let me just go through my notes here. Testnet faucet, we've done that, done payments. Great. So the next thing I'm going to show is how you can interact with this with code, because that's great being able to do it through the app, and that can hopefully show you how nice and easy it is to do payments through an app like Sum. And Sum is just one wallet app. There's a number of wallets out there that support XRP as well. Just Sum is probably the best one, I would say, for this. Now, I'm going to switch over to some code. So 1 second here. I want to just rearrange some windows here a second. It says I've got the, need to just move this one out of the way. There we go. And just move this over here so we can see it still. Right. Okay. So on the left here, I've got some Python code. There's various ways you can interact with the XRP ledger. You can use JavaScript, you can use Python, you can use Java, you can connect directly via XML, RPC, or WebSockets to make connections there with that. I'm using Python because Python's a very kind of high level, quite easy language. And so I can actually describe this, and hopefully, so even as a programmer, hopefully you can take a little bit away from this. So what we're doing here. So first of all, we import a number of functions and utilities from the library XRPL Pi. So there's a client library XRPL Pi for Python, XRPL JS for JavaScript, and XRPL 4J for Java. And I'm going to be connecting to the testnet. So here I've got the address of the testnet. Now it's a slightly different address to what you had in some, but it's the same network, right? But it's just showing a different host there. This is one that's hosted by Ripple. And I want to send a payment. So I need an address here, a wallet secret key to send. So that's the one that starts with an S because that's a secret. I need to sign a transaction, and I need the receiving address, which is this one here. Now I think, let me just double check and see if I've got the right one. Is this my address here? No, I've generated a new one here. So 1 second, let me just copy this. I copy that there. I can paste that in here. There we go. It's the same address, ends in 4D. There we go. And I can send an amount here as well. So I'm going to send 23 XRP, or there we go. Let's go 88 XRP. I instantiate a wallet there using the sender's wallet key. I'm just going to print out that it's sending and receiving. I construct the transaction, and it's a payment transaction. It's going from the sending wallet's address. I've had to convert the amount into drops because the API uses that smaller denomination drops there, so it doesn't have to deal with decimals. The destination is the receiving address, which I've set here, which is my address in sum, and the fee, which is 10 drops. I then need to sign the transaction. So that's signed using the sending wallet that we've defined there, and we send it. So this is a function here that will connect to the XRP ledger, send the wait the 3 seconds for it to come through, and then return the end there. So let's run this then. So if I do it here, I should be able to do Python. What was it? Simple payment. There we go. So if I send that, sending and receiving, and hopefully what you should see is you should see it pop up in my Sum wallet when that goes through. There we go. 88 XRP. It's just popped up. So it's actually gone through there. And so that's just a demo of using code to actually send it. So that's how easy it is if you want to integrate in the XRP ledger to your own applications. That's just an example of doing a payment. Now, like I said, you can do a lot of other things with the XRP ledger because you can actually trade using the decentralized exchange. You can make cross-currency payments. There's a lot of different things that you can do there. Now, I mentioned tokens, and one of the things I'm going to do is I'm going to issue Singapore dollars on the XRP ledger. So this is, simulating that I might be a financial institution and I want to tokenize Singapore dollars. So the idea would be that somebody would deposit Singapore dollars with me, and in return, I would give them tokens on the XRP ledger that represents that. So if you deposited 100 Singapore dollars, I give you 100, tokens that represent Singapore dollars on the XRP ledger. Now, this code's a little bit longer, but so I'm not going to go into the full details of it, but just to say that you have effectively a cold wallet and a hot wallet. The cold wallet is the issuer of the asset. The hot wallet is the kind of the operational wallet. Sorry, is there somebody there in the chat? No? Okay. I can configure the account here, and I'm going to configure both the cold and the hot wallet addresses. And I'm going to create what's called a trust line for Singapore dollars. and this is what's going to actually issue these Singapore dollars. So I'm going to issue that. I'm going to say up to, is that 1 million, billion, 10 billion. I'm going to actually issue 3,840 arbitrary chosen number Singapore dollars, right? Similarly, I sign and send the transaction. So like I said, I'm not going to go into the full details here, but I will run this, or let me just double check that the wallet address here, I think this is all correct. I may have already run this. So let's, I think I've already run this. So what I will do is I will actually move on to the next one, because if I run this again, it'll probably fail. But what I can do is I can, once I've completed that, I can actually pay Singapore dollars. Now I need to set up this trust line here. So let's see here, the destination address. I need the secret to this account here. And that will be, whether this is the correct one or not, let me just double check here. I can't remember whether I noted the secret down before I did this when I created this account. Let me just quickly go back to the, oh no, it was on the phone, wasn't it? Let me just check here. If I go back to Safari, here we go. I've got the address here, the secret. So I just need to copy that. It ends in 65. So let me just copy that and paste that here. No, that's not the right thing. Try that again. Copy. And, oh, for some reason, that is not copying and pasting that through in there. And I'm not going to type that all out because that's going to take a while to type that all in there. Let me do it quickly then, just quickly, because this is quite good to show, because it will show how you can actually create currencies and issue them on the XRP ledger, and I'll be able to then send people Singapore dollars if we have enough time. We may not do. Right. Okay, let's run this then. Hey, SGT. Now, if I go back to my Sum wallet, go back to the home there, right. Let's try that then. The demo gods are smiling on me, hopefully. So what this is doing is, first of all, it's setting this, there we go. It's set the trust line, so it says I can hold Singapore dollars. So I've done that, and now it's sending 60 Singapore dollars to my account. And there we go, 60 Singapore dollars. So I now have Singapore dollars in this account as well. And I could, like I said, I can pay with Singapore dollars. I could transfer those to somebody else, or I could use the decentralized exchange to exchange them. Just bring up the chat here. So somebody's asking, CK is asking whether the XRP ledger's underlying building language is Python, as in Ethereum is using Solidity. So there's various languages you can use to interact with the XRP ledger: Python, JavaScript, or Java. Those are the languages you're using to write code to interact with the XRP ledger. This is not running like a smart contract on the XRP ledger. So the XRP ledger at the moment doesn't have on-chain smart contract functionality. The reason being is that most of the functionality you need smart contracts for is actually natively built into the XRP ledger. So all of what we've done, what I've just showed you in terms of issuing your own currency, is a native function on the XRP ledger. If you were doing that on Ethereum, you would need a smart contract to create what's called an ERC20 token. But the XRP ledger has built in things like tokenization, a decentralized exchange, escrow functions, multi-signature functions. All those things are built in natively, so you don't need you don't need smart contracts to do that. That said, there is a thing called hooks that is being worked on at the moment that will allow arbitrary kind of smart contract functionality on the XRP ledger. So that's the kind of demo bit done here. How are we doing for time here? Okay, 45, okay. So I'm now going to talk just a little bit about kind of the sustainability and impact of the XRP ledger. As I mentioned at the start, one of the great things with the XRP ledger is it uses much less energy than the likes of Bitcoin. And this was designed right at the start. So the XRP ledger was actually created by 3 Bitcoin developers back in 2011 who saw the issue with proof of work, which is a consensus mechanism that Bitcoin uses. They saw the energy requirements even 10 years ago, and obviously it's much greater energy requirement now. And so they sought to create something that would be as decentralized as Bitcoin, but without the energy requirements. And they came up with the XRP ledger consensus protocol and created the XRP ledger instead. So the XRP ledger uses, like I said, this more efficient consensus mechanism rather than proof of work that say Bitcoin and Ethereum use at the moment. And kind of putting the numbers on that, so Bitcoin as of March earlier this year, Bitcoin was using about as much power as the entire country of Portugal. You've probably seen a lot of this kind of sort of comparisons, whereas the XRP ledger is a tiny, tiny fraction of that in there. I mean, even if you compare to something like cash still uses a fair amount of energy when you factor in all the processing of it as well in there. And then if we compare it to other cryptocurrencies and actually sort of look at the numbers, comparing it in sort of various ways, one of the easiest ways to kind of visualize it is things like gallons of gas. So about 75 gallons of gas per transaction for a Bitcoin transaction, 2.3 gallons of gas per transaction for an Ethereum transaction, whereas we're talking 63 thousandths of an address of a gallon. So 63 thousandths, yeah. Or even less than that, 63 10,000ths of a gallon per transaction on the XRP ledger. So a lot more efficient, and as a result of that, a lot less CO2 emissions. So one of the XRP ledger was the first major blockchain to become carbon neutral. So it has very little emissions anyway, but then the XRP ledger Foundation has actually bought carbon credits to offset the very small amount of energy that it does use. And so it's actually carbon neutral, and Ripple and the XRP ledger Foundation have been working with an organization called Energy Web to actually kind of look at the energy requirements of cryptocurrencies and blockchains. And this, again, going back to one of the sort of topics of currently of the day, a lot of people talk about NFTs. This is obviously a very pertinent thing with NFTs, because a lot of, say, artists are looking at minting NFTs. And I actually saw one comment from one saying, well, I might as well just go and burn down a rainforest instead. And the thought was that there's so much carbon emission from doing things like issuing an NFT on the XRP on something like Ethereum, whereas if you do something like that on XRP, on the XRP ledger, it's much less energy usage. So how can XRP drive greater financial inclusion? As I mentioned right at the very start, the cost of things like cross-border payments, the cost of accessing financial services can be very expensive for some people. And the ability to use XRP in that way can actually have quite a dramatic effect on, people's lives and their livelihoods. And not only that, but it kind of changes the whole way in which transactions can occur. So we've talked a bit about remittances. I've talked a bit about DeFi, small payments. If you're going to send some money home and you're going to use the likes of Western Union or something like that, and you want to send $10 home and it's costing you $5 per transaction, you're not going to do that. You're going to wait until you've saved up $100 and make that. If you are wanting to accept payments. So think about things like a newspaper website, right? You've probably come across newspaper websites or magazine websites, information websites that have some kind of paywall, and you have to put in your credit card and subscribe for some sort of monthly subscription. Well, the reason they have to do that monthly subscription is because it's not economical for them to take a credit card payment for less than, say, $5 or $10, right? They can't take a credit card payment for 10 cents to allow you to read that article, that one article, because the cost of the transaction is so much higher, right? You're going to be paying 50 cents or whatever it is per transaction for a debit card, transaction. So with the XRP Ledger, because the transaction fees are so low, you can actually come up with completely different business models. So for example, there's a company called Coil that are actually doing streaming micropayments. So as you are reading a blog post or watching a video, your browser is sending payment to that content creator, literally every few seconds, right? So every few seconds, it is sending, a thousandth of a cent or whatever it is, however much it is to the content creator. When you stop, it stops, right? So you're really just paying the kind of exact amount for what you're using. And that means that you don't have to, take a credit card payment, which means you don't have to take their address in order to verify the credit card payment. You don't have to have them create a username and a password such they can come back to their account to use the credit that they've paid for, right? All of those kind of things go away when you can just literally pay as you go along, because as soon as the payment comes in, you can issue the currency there, or the service. So the opportunity around digital payments are accelerating. You've probably seen now this is a great trend. It goes back to the trends I mentioned at the start, that the cryptocurrencies are growing. They're being adopted in wider context within fintech, beyond fintech as well, and they really have the opportunity to kind of foster financial inclusion for people. So that's kind of what I want to leave you with. Is that's kind of the goal that we're aiming for here in the end, is hopefully building better financial services, more equitable financial services, more affordable financial services to everybody across the globe. So thank you very much for your time, and my contact details are there if anybody has any wants to reach out at all. But I'm happy to take some questions now. I see we've got a question in the chat as well here. So CK asks, how do we measure energy requirements and carbon impact of XRP or any DLT? Are there any instruments, programming language? So it's, or is it from the company's monthly utility bills? Yes, effectively it's from utility bills. So in the case of the XRP Ledger, you can work out, okay, how many nodes are there on the network that are running? What is the power consumption per node on average? And work it out based upon that way. So yes, it is an approximation, but it's possible to do that. With things like proof of work networks, they use a lot more power, but again, you can kind of look at the what's called the hash rate that they're producing, and from the hash rate, you can calculate backwards to the amount of energy consumed, and then from there, you can calculate, emissions or cost based upon that. There's a move to greener energy sources for things like proof of work. The main problem with that being is that proof of work, by its very definition, the way in which it works is proof of work requires energy to be scarce, right? Proof of work works by basically introducing an artificial scarcity around energy. Now, energy obviously is scarce. Within certain parameters, it is finite. But if you then start using renewable energies, you start making energy, you start saying, okay, well, I've got a cheaper form of energy or more available form of energy to use for say, Bitcoin mining. All that Bitcoin will do is increase the difficulty level such that it consumes more power, right? So it doesn't really matter that you're finding more greener energy, because all that happens is Bitcoin will just consume that. And that's then energy that's not necessarily available for other sources as well. So there we go. Right. Any further questions? If anybody has any questions, feel free to put in the chat or come off mute. CK asks, roughly how much is Ripple's monthly electricity cost? Is okay to share here. So it's not Ripple's cost, it's the XRP Ledger as a whole. So the XRP Ledger, let me just bring up here if I just, oh, no, sorry, live net. There we go, network here. So here is a kind of map showing the nodes on the XRP ledger. There's over 800 nodes on there, and it kind of shows the status kind of them on the network there. So from there, you can basically try and infer the costs and the energy usage from there. So I don't know what the full amount is. There's a like I said, there's well, if you go to ripple.com/impact, it's impact. I think it's impact. No. We have actually done some stuff here. Oh, okay, here we go. So it's on not on Ripple site, it's on the XRP Ledger site. So there's a couple of sites here. So if I put in this here into the chat, then if anybody wants to find out more, xrpl.org. And there's actually a tool here. There's a carbon calculator on here you can go into that gives you a lot more information there, and you can actually calculate it yourself there. So I'll put the link there. And this site here, this xrpl.org has a lot more information about the XRP ledger, how you can access it, how you can get involved in the community if you want to, the features of the XRP ledger, and it's got all the documentations for development. So talk about, like I said, languages, we've got SDKs there, and you can go into these, and there's actually some tutorials in there as well that you can follow along with. So the code that I ran earlier for issuing a token actually came from a tutorial we have here, issue a fungible token. And that tutorial kind of takes you through all the steps there in different languages. So I think there's possibly a question coming from Glenn. Yeah, it just says, dear Matt, Alex Limbs, why doesn't XRP have smart contracts? So this was a design decision at the start. So the XRP ledger was the second major blockchain after Bitcoin. It came about 3 or 4 years before Ethereum did, and really before the whole idea of smart contracts had taken off. In fact, the creator of Ethereum, Vitalik Buterin, actually interned at Ripple several years before he actually created Ethereum and smart contracts. Now, Ripple actually went down the approach of creating off-chain smart contracts. So they were working on a project called Codius, and Codius was a smart contract system that runs off ledger. So the idea was that the designers of Codius didn't want smart contracts to be so directly tied to the ledger, because that meant only one ledger could use them. So Codius is actually connected to interledger, which I mentioned before. So interledger it was a standard that was created by Ripple. It's now its own separate thing. This is the Interledger Foundation, and Interledger is a network a standard for interconnecting different blockchains, right? And Codius connects to Interledger. So the idea was that it would be agnostic to whatever blockchain you wanted to use. And that's the way they kind of created it. And it's a bit more flexible. However, on-chain transactions like those on Ethereum have certainly gained a lot more popularity. People have been interacting with them a lot more. But I mentioned there's a system called Hooks, and Hooks is being developed by a group in the Netherlands called XRPL Labs. Actually, the same people that created the Sum wallet that I was demoing earlier. And Hooks allows you to create bits of code that will function on when a transaction is received by an account. So you could do things like say, okay, whenever any payment comes into this account, take 1% of that those incoming funds and send it off to this charity, for example, or don't accept any payments, deny any payments that are less than a certain value, for example, right? So you can create different functions there that will run in a similar way to smart contracts. So they're going to be coming soon. There's a test net, so you can play around with them, and they'll be on the main XRP ledger, hopefully sometime next year. It has to be voted on by the participants of the network. So Glenn asks, can the Ripple be used as a form of Forex, for example, sending from a wallet W Singapore dollars and receiving in another? Yes. So yes, you can use issued assets on there. So I issued Singapore dollars on there. There's US dollars, there's euros, etc. on the XRP ledger. So you could use the XRP ledger directly for fiat currencies, right? You could create a fiat currency, remittance system on the XRP ledger, and no one would even necessarily know that you're using cryptocurrencies. They wouldn't have to have any interaction with cryptocurrencies. As far as they're concerned, they're using Singapore dollars and are able to make payments in US dollars or euros or whatever they want in there. They don't have to use cryptocurrencies because you can pretty much tokenize anything. So we're out of time. If anybody has any more questions, then feel free to get a hold of me. My contact details, I'll put my email address here in the chat. And you can get me on Twitter there as well. So once again, thank you very much for having me.
Matt, that was a great session. Before we conclude this session, can we have a picture together? Everyone can switch on their camera.
That'd be great. Should I stop sharing?
Can everyone turn on your camera? Let's have a photo together with Matt.
Okay, I think if I stop sharing, that'll make that easier.
Is everyone following? Yeah. Okay.
Go ahead.
No, it's okay, bro. Yeah, take a picture.
You took the picture already? I'm not taking. I'm not at my desk.
I'll take. Okay.
Thank you. Just count down. 5.
1, 2, and go.
All right.
One more.